Sorry about that. The sound didn't start until right now. So I'm in the habit in the morning of putting the mic on, but here, the past couple days, we haven't been doing this. So anyway, we're just putting together the divided difference method, Newton's divided difference method, not due till next Wednesday, but I don't think we covered it at least well in class. So we're just going to do a quick at least setup of the function. We might not finish it today. So anyway, you've got this, and then I'm going to just get the length of these two things. So in x is going to be the length of the vector x, and in y, oh, sorry, I never finished my thought here. I got distracted by my microphone. So this is going to produce the polynomial coefficients from the divided Newton's from Newton's divided difference method. Okay, just if you want to know what it is that we're doing, that's what we're doing. So I'm going to say that in x is the length of x, and in y is equal to the length of y. And then just to make sure that someone isn't being dumb, I'm going to say if in x does not equal in y, then I'm going to have an error. If that happens, then we're going to just return some sort of statement like, hey, x and y have to be the same length. I don't know, something like that. I'm sure I'm not thinking of all the different errors that people could make when they try to use this function, but at least that takes care of that. Okay, so next, so here's the strat. Oh, well, here, we'll just do this really quick. I'm going to call A is going to be a copy of Y. Copy, okay, whatever. So I think that that's the way we do that. So that it's a complete copy, it's not, so there's no relationship between A and Y, it's just, so here's the idea, that, the way that this is going to shake out, and then I'll go do it in the code. I know, huge mess. So let me erase this. Whoa, not that much. Just a sec. Erase this. Okay, so here's the idea, is when you start this method, you're given these two columns. Whoops, come on. What's going on? You're given these two columns. This is the X column. This is the Y column. So that's what we've got when we start. That's the inputs. And my goal, let me get rid of that so that it's not in the way. Oh no, come back. So my goal is to get this here. So that's the output. So here's the idea, is I'm going to call the output A. That's going to be my A, this vector A. And you'll notice that the very first number in the output is the same as the first number in the vector Y. So here's the strategy I'm going to do, is I've got this output, and when I start off, the output, the A, is just the same as whatever I input, my Y. There it is. I'm not going to mess with that because I know it's going to be that, whatever that is. So let's not mess with that. But here's the strategy, is I'm going to compute these three numbers. And when I do those three numbers, I'm going to just overwrite, like, so essentially, here's how this is going to look, that when I first start off, A is going to look like this, 0, 0.5, 0.86, and 1. And then after the first round of computations, these three, A is going to look like this. I'm going to get rid of these, and in place, I'm going to put 0.95, 0.699, and 0.26, whatever. So you see, that'll be the most efficient, because then now, because I don't need these numbers anymore to compute these. So each time I run through this, and then I'll do these divided differences, and then if you can probably guess what's going to happen, I'm going to put those two numbers in place of these two up here. And then when I get to this last one, I'm going to be like, well, you know, I don't need that number, which is in this position. I'll just plug that in there. So that's the strategy that I'm going to be going through. And this is usually what the strategy is for Newton's divided difference method. You kind of just, it's more efficient than trying to keep that whole, there's no reason to have all of those numbers, since the only ones we need are those 4 or whatever the top diagonal is. So that's the strategy. Let's just set up the divided difference, because that's the hard part, is just to understand how to, well, here. So for I in range 1 to n, okay, I'll explain what these are going to do in just a sec. And then for j in range n minus 1, I minus 1, minus 1. Okay, I'll explain here. Let's see, can I put these both up here? I don't think I can. Okay, so here's the idea. Here's how I'm counting I. I is going to be, this is 0, column 0. Then this is 1, and this is 2, and this is 3. So my I, the counter I, it's going to go 1, 2, 3. And if there were more nodes, then it'll just keep going. So that's what I does, is I is keeping track of which of these columns I'm working on. And then J, what J is doing is it's figuring out which of these numbers within the column you're working on. And I'm going to start from the bottom and work my way up instead of the top and going down, because when I compute this number, I'm going to use these two numbers. And then once I compute this, I'm going to put this in the place of that 1 there. And then I don't care that the 1 has disappeared, because when I compute this, I'm going to use these two numbers. And I'm never going to use that 1 again. So now I'll compute these, and then I'll take whatever my answer is, which is that, and I'll stick it where that 0.866 was. And then finally, I'll compute this and stick it where the 0.5 is. So that's why it looks like I'm working my way backwards, which I am. And as far as the I minus 1 goes, that's just experimentation and figuring out exactly where we need to stop. But you'll just have to trust that that's the right answer there. So the I there, you're going column by column. This, you're starting at n minus 1. So you're just going to work your way backwards, if you will, starting at n minus 1, working your way backwards. That's what that means, down to I minus 1. So we could actually print these. In fact, we will. Let's yeah, maybe we should, so that we can see how this works. Oh, this is a great idea. Oh, okay, actually, I've got it. I'm so happy. I just realized I can do half of the job for you, and you can do the other half for next Wednesday, because this is the hard part. The rest of it is easy. Okay, so here's how this is going to shake out. Your A sub j, I'm going to write a divided difference here, and it's just, whoops, the main difficulty here is just keeping track of what is happening in terms of this chart. Like if I'm dealing with this number right here, I'm going to do these two divided by these two. So it's just trying to keep track, doing the bookkeeping. That's the hard part. But let me do it for you. So A sub j is going to be the previous difference. So you're doing a difference between the previous. So A sub j minus, and it looks like I'm referring to it's not recursive. Don't worry. AJ minus 1. We'll review and make sure it's all correct in just a sec. So here's the deal, is that all that's saying is that this number over here is equal to this minus that, which if you're tracking things up at the on this, it's let's see, it's this number minus this number. So the number that I end up putting here will be this 0.699 minus the 0.95. So I'm gonna just, so that's all that's saying, is I'm gonna put a new number where the old number was, but I'm gonna use the old number in the calculation. So there's that, and then you divide by the x values. So I have x, and here, this is the tricky part, I feel, is xj minus xj minus I. Oh, I need parentheses. Hold on a sec, because that's got to be on the whole thing in the denominator. There, I think that does it. I hope so. Yeah, I think that does it, because that's x. Okay, yeah, that should do it. So just to keep track, if you want to see what I just did there. So this, I know it's gotten so messy now. I'll just change color. That this number is these two. So those are right next to each other. But then notice that that number is going to be here in the third position. You go down to the third, actually, you know how Python is. It'll be number 2, because we count at zero, start counting at zero. But this number minus this number up here. And the difference between those is 2, and that's where the j comes in. So that's why it's xj minus I, because I'm on the second column of calculations. Here's the first column, here's the second. So here's the difference between those two. But you can either say, oh, that's great, or you can just be like, oh, I believe you and trust you. However you do it, we're pretty much done now, because now we just have to return A, and we'll check our work and make sure it works. So let's go ahead and try this out. Let's see, xlist, I probably should have called it xlist, shouldn't I? Too late now. Xlist is going to equal, let's use the numbers in this table. As messy as it is, I'll erase all my ink before we check them. So the xlist is going to be 0, pi over 6, pi over 3, and pi over 2. So that's the x's. And then the y's, y list, are the signs. Is that what these are? Yeah, those are signs. So y list, whoops, is going to equal sine of 0 is 0, sine of pi over 6 is 0.5. This is the square root of 3 over 2, and then this is 1. Wait. Yeah, that's right. That's the same. Okay, so now I'm really curious to see if this works. What was this called again? Divided difference? Divided underscore difference of x list and y list. And I should print this, shouldn't I? Let's go put a print statement. And then I'm going to be despondent if it fails. Okay, it's thinking, it's connecting. I guess I should have, you know how it is with this, is that it always takes a minute to start. Oh no, why? Just a minute, what's wrong here? I never said what in, okay, I'm on the wrong screen, just a sec. Here, that's the problem. Oh, in X, okay, I'm sorry, yes, this should be in X, okay. Since I've already typed all that junk, I'll just do this, that in is equal to nx. That was kind of dumb of me. Yeah, I just wanted to make sure at the front end, that's sort of unnecessary because, yeah, this business, this if statement and all of that, I was just checking to make sure that you had 2 vectors of the same length. If I hadn't had all that, this would have just been 5 lines of code, which would have been, or 6 lines of code, which would have been nice, but oh well. Let's go ahead and see how this works. Does it work? Oh, it does. Oh, good. Is it the same numbers? Oh, it is the same numbers. It's this here. Let me just show you that it's the same numbers. Here's, I'll erase this. Erase, there we go. So these numbers are the ones that we care about. Those are the coefficients, 0.95, negative 0.24, and negative 0.11. And notice it's those same numbers. I'm so happy it worked out. By the way, we can actually get the entire table, sort of, if you print. So if you put a print statement, where would I put it? Maybe right here? Maybe right here, right before the return? No. Sorry, yeah, this is kind of extra. Here, right here, print A, maybe right there. Let's try that. Let's see what happened. Did it print? It doesn't have the whole table, but it has some of the intermediate results. And if you compare those intermediate results with this, which is the one that I computed a couple years ago, but it's the same thing, you'll see that those numbers all match up. Let's get rid of that print statement. It's unnecessary. Okay, so that gets you started. So you get to do the other half. The other half's the easy half, though. So here's what you're going to do is you're going to construct a new function. So the second function is this. Whoops, let me get my notes. Okay, so the second function is this. You're going to define a function called evaluate. evaluate, we'll just call it evaluate. You could call it evaluate Newton if you want, but that might be a little bit more descriptive. But you're going to have X, then I'm going to call this X list, and then A. There we go. And here, I'll put a little comment here. You're going to evaluate Newton's. You don't have to add this, but it might help you to know what your job is. Divided difference polynomial at x equals, or at x, okay, where x list is the list of x values used to generate the coefficients A. So the A is the list of the coefficients, basically the output from this down here, divided difference, and the X list is the same, it's whatever you use, so you'll use this. So when you do this, to check to see if it works, you'll do this, and then you'll do this, print, evaluate. Now that I know I can press escape, I'll do that. And you're going to do X. Let's see, what are we going to use for X? Pi over 4? Sure, pi over 4. And then we use the X list, and then the output, which is A. I think that's it. So I guess I need to change this. Hold on a minute. So, oops, sorry. So A is equal to the divided difference. There we go. So right now this thing is empty, but you're going to need to fill this thing up. Oh, I need a colon. I keep forgetting my colon when I put a comment in. So you'll want to stick something in here, and basically what you're going to stick in there is an evaluation of this polynomial. Now, if you're not sure how to do that, I'll come help you. We can talk about it. But basically, you've got the coefficients, you have the x's. There's a bunch of different ways to do it, some less efficient than others, but it doesn't matter how it looks. Like I said, I can help you write down the polynomial. Do I have it? I guess I have this. That's not very nice. Not a very nice version of it. I don't like that version of it. But basically this, so that's going to be a sub 0. And then this thing, instead of that, I would put a sub k. So the different coefficients times the product of all of those things. All right, so that's at least a quick overview, super brief. I know it's super brief of Newton's divided differences. So the rest of your time, we have time to deal with the whatever the aftermath of anything that, like, you've got the polynomial. Let's see, sorry, root finding due today. If anyone's still straggling on that, I can come help you. We have the Lagrange due Monday. So if you're still stuck on that or graphing, I can come help you with that. And then if you're more advanced and you want to just polish this off right now, you can go ahead and do it. There's the formula. I'm going to stop the recording because it's boring to hear me mumbling to people as I walk around. But also I have to end a little early today because I need to go set up